Hey there, and welcome to my channel, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we're slowing things down a bit to wander through one of the most extraordinary and humbling chapters in our planet's history. You've probably heard the sound of rain before, soft and rhythmic against your window. Maybe it's lulled you to sleep or kept you company while you stared out into the grey, thinking about everything, or nothing at all. But imagine for a moment that the rain never stopped. Imagine a world where that gentle sound wasn't just a passing weather pattern, but the background music of existence itself. Not for a day, not for a season, not even for a year, but for 2 million years straight. It sounds impossible, something out of myth, but it really happened. Long before humans, before forests, before fish, or even blue oceans, Earth went through an age of rain so relentless it reshaped the entire planet, from its molten core to the clouds above. It's a strange thought, isn't it? We usually think of rain as something gentle, even romantic. But in the early life of our world, rain was raw transformation, a storm on a planetary scale. It was the downpour that turned a world of fire into a world of water. It cooled an atmosphere thick with heat and gas and transformed it into air that could one day cradle life. This wasn't the kind of rain that fills puddles or taps softly on rooftops. This was a deluge falling from skies made of steam onto rocks still hot enough to glow. It didn't come and go. It didn't pause for sunlight. It just fell, endlessly, until the very shape of the world beneath it changed. Pause. Conversational break to connect with listener. Before we dive deeper into how something like this could even happen, where are you listening from tonight? Is it raining where you are? Or maybe it's calm and still. Perhaps it's night time, and you can hear that soft hum of the world settling down around you. Or maybe there's that thick, quiet air right before a storm. Wherever you are, let this story unfold slowly. There's no rush here, no thunder, just the gentle rhythm of understanding how Earth once washed itself clean for 2 million years without rest. And hey, if stories like this soothe you, if you enjoy that calm curiosity that lets your mind drift through science instead of worry, I'd be so grateful if you'd like the video or subscribe to the channel. It helps this little corner of calm find others who might need a quiet moment to marvel at how strange and beautiful our planet truly is. Now, settle in, breathe a little slower, and picture the world as it was 4 billion years ago, long before it became the home we know today. Because to understand endless rain, we first have to step into a time when clouds were still being born. Main story. Vivid world building. In the beginning, Earth wasn't blue. It wasn't green or brown or peaceful in any sense of the word. It was red, black and glowing, a molten sphere still shedding the heat of its violent birth. The surface was a restless ocean of magma, shimmering with its own light. The air was thick with smoke and volcanic gas. There were no oceans yet, no rivers, no real clouds. Just a heavy haze of chemical vapors rising from deep within as the planet tried to decide what kind of world it wanted to be. But hidden inside all that heat was the future, the seeds of everything, including rain. Scientists believe much of Earth's first water was trapped deep within those molten rocks, or delivered later by icy comets crashing into the young planet. Each impact brought new materials, more gases, more water vapor, adding to an atmosphere so dense that sunlight could barely break through. The air was a boiling soup of carbon dioxide, nitrogen, methane, and steam. For millions of years, it simply swirled above a glowing crust, waiting for the world to cool enough for all that vapor to finally condense. Just imagine the pressure, the sheer weight of that atmosphere pressing down on a planet still too hot to breathe. The water couldn't fall yet. It was trapped as invisible vapor in a sky shimmering with heat. The rain was waiting, patient, building itself drop by drop in a world that didn't yet know the meaning of sky, time shift, storytelling rhythm. We measure time in hours, days, years. But in the early Earth, time didn't move like that. Back then, every day lasted only about 6 hours. The planet spun faster, tugged and twisted by a moon that hung much closer in the sky than it does now. Volcanoes erupted constantly, spewing ash and gas into the air. Lightning ripped across the thick, charged atmosphere, sparking chemical reactions that turned simple molecules into complex ones, the building blocks of life. It was chaos, but creative chaos. The kind of chaos that builds rather than destroys. The stage was being set for the first rainfall, the one that would cool the planet's surface, shape the continents, and form the oceans that still move beneath our clouds today. Climax. The transformation begins. After hundreds of millions of years of fire and fury, Earth finally began to cool. The searing heat from its birth slowly faded into space. The crust started to harden, forming the first solid patches of land, primitive continents surrounded by glowing lava seas. The air, still heavy with vapor, began to shift. And then, somewhere in that slow, quiet transition from fire to stone, something miraculous happened. The first droplets of liquid water formed high above the planet. They began to fall, tiny droplets breaking free from the clouds, tumbling through a dense, steaming sky until they struck the blazing ground below. Each drop hit the surface and vanished instantly in a burst of white vapor. But with every fall, the planet cooled, just a little. Every droplet carried away a trace of Earth's fever, condensation, evaporation. Over and over, a slow exchange between sky and stone. Each cycle nudged the world closer to its first true storm. And then, one day, the balance tipped. The vapor condensed faster than it could turn back to steam. The sky gave up, and it began to rain. If you could have stood on that newborn Earth, though, of course, you couldn't have survived the heat or the air, you'd have witnessed something both terrifying and magnificent. The sky would have been almost black, crowded with clouds so thick they turned day into a permanent twilight. Lightning flashed through the vapor, lighting up curtains of rain that fell with no horizon, no pause, no end. The sound would have been unlike anything you could imagine, a roaring symphony as billions of tons of water collided with rock and fire. Steam erupted where the rain met lava, carving deep channels through molten plains, cooling the surface into glass, and sending vast plumes of vapor back upward to feed the clouds again. It was a loop, a self-sustaining cycle that didn't stop, not for a day, not for a season, but for 2 million years. This wasn't a storm in the way we think of storms. It wasn't a front drifting through or a temporary tantrum of the weather. It was the sky, the entire atmosphere locked in the work of cooling a world. As the deluge continued, the planet's surface temperature dropped even more. The water that once flashed instantly into vapor began to stay, pooling in the lowest valleys, gathering into shallow lakes. The lakes joined together, spreading wider until the first oceans began to take shape. Under an endless grey sky, the world slowly shifted from glowing red to deep, shimmering blue. Earth was changing its face, trading fire for water, under a sky that never stopped weeping. You might wonder how scientists could possibly know any of this. After all, no one was there to see it happen. The clues lie in the oldest rocks we've ever found. Ancient minerals, tiny zircon crystals discovered in Australia, hold within them chemical fingerprints from that distant time. Some of these crystals are more than 4.3 billion years old, and inside them are traces of liquid water, proof that oceans existed far earlier than we once believed. The isotopes locked inside those crystals tell a story of cooling, condensation, and endless rainfall, lasting for unimaginable spans of time. It's not poetic exaggeration, it's written in stone. The idea that Earth reigned for 2 million years straight isn't mythology, it's physics. It's the thermodynamics of a planet releasing its trapped water, moisture sealed deep within its crust, escaping drop by drop through an atmosphere thick with heat and gas. Each droplet absorbed a piece of that heat as it fell and released it again when it turned back to steam. Eventually, the balance shifted. More water reached the surface than could return to the clouds. The vapor cycle collapsed, and the deluge finished its work. What began in fire ended in ocean. Think about that patience. 2 million years of constant rain. Every hour, every moment, the same ceaseless rhythm. No dry season, no sunlight breaking through. Just endless clouds, trapping their own dim glow, turning the planet into a world of perpetual dusk. And yet, beneath that monotony, transformation was unfolding. The crust was solidifying, the air was thinning. Rainwater reacted with minerals on the surface, scrubbing carbon dioxide from the atmosphere and forming new compounds that stabilized the planet's temperature. The rain wasn't destruction, it was therapy, the planet healing from its violent birth. If you've ever watched a storm roll in, felt the hush before the first drop, smelled that raw mineral scent in the air, you've experienced a tiny echo of what the Earth once went through on a planetary scale. It's humbling to think that the water falling outside your window tonight is part of the same cycle, the same molecules that once hissed against molten rock billions of years ago. The sound of endless rain isn't imagination, it's memory. The memory of how this world found balance after chaos. That rain carved the first oceans, cooled the crust, and prepared the stage for life itself. Even now, traces of that time remain. Every river that winds toward the sea, every storm that crosses our skies, carries within it a faint rhythm, an ancient echo of those primeval rains. When you think about it that way, rain becomes more than weather. It's continuity. It's the thread connecting the first storms of Earth to the gentle showers we feel today. It links the planet's fiery beginning to our quiet nights, when we listen to water and somehow feel safe. Maybe deep down, something in us remembers that sound, that steady, endless fall of water against the world, as the first song of peace our planet ever played. Eventually, the rain began to slow, not suddenly, but gradually, as the surface cooled and the new oceans deepened. The sky lightened, clouds thinned, steam softened into mist, and the constant roar faded into the rhythm of waves. Through the thinning haze, a dim red sun appeared for the first time, weak, filtered, but steady. The world beneath it was unrecognizable from the one that came before. Where once there had been seas of lava, there were now true oceans. The air was still heavy, but calm enough to support the fragile chemistry that would one day become life. The storm had done its work, and for the first time in the planet's history, there was quiet. Not silence, but the soft, eternal breath of a world cooling into peace. The rain didn't need to be violent anymore. It had become steady, nurturing, the first lullaby the earth ever knew. That's where our story begins, with the sound of endless rain. A planet that once burned itself into existence was finally learning how to rest. Steam turned to clouds, heat softened into calm, and the furious energy of creation began to slow into something almost gentle. This is how the oceans were born. This is how the earth learned patience. And in the quiet that followed, the world waited for what would come next. A time when the rain would finally stop, when sunlight would touch the water, and the calm surface of a newborn sea would mirror the very first blue sky. The world that emerged beneath that endless downpour was unlike anything that exists today. It was still restless, still unfinished, still cooling the last of its fury. The ground, where it managed to exist at all, was dark and fractured, carved by torrents that never paused long enough to dry. Rivers with no mouths rushed downhill into basins that filled faster than they could drain. Every surface hissed when the water touched it. The air sizzled, rocks cracked, and the heat that had once defined the planet bled slowly into the sky. The storm wasn't a single event, it was a process, a 2 million-year transformation that blurred the line between ocean and atmosphere. And though the rain eventually ended, its memory never did. Every ocean, every river, every drop that falls today is a faint echo of that forgotten storm that once never stopped. At this stage in Earth's story, the continents we know didn't exist yet. The planet was more a patchwork of cooling crust than solid ground. Volcanoes erupted across the surface like open wounds, spilling lava into temporary basins that hardened only to crack again. Above, the clouds were heavy with carbon dioxide and sulfur dioxide, remnants of the violent volcanic age that came before the rain. The entire atmosphere was choked with water vapor, and once the temperature dropped low enough for condensation to begin, the process became unstoppable. The planet had crossed a threshold, and nature doesn't do anything halfway. Once the rain began, it wouldn't end until balance was restored, until the crust and the clouds finally agreed on what kind of world this was going to be. Today, storms are brief interruptions in a stable climate. They form, release their energy, and fade. But 4 billion years ago, there was no balance to return to. Earth was nothing but extremes, and this storm was the tool that erased those extremes. Every droplet pulled heat from the crust, and multiplied over millions of years, that small act of cooling reshaped the entire planet. As vapor condensed, air pressure dropped. As the surface absorbed rainfall, its heat vanished into the atmosphere. The difference between sky and ground began to narrow until both found a fragile equilibrium. It wasn't fast and it wasn't kind, but it worked. The storm that never stopped was the act of balance that made Earth habitable. If someone had looked down from space during that time, they might have struggled to see where the atmosphere ended and the oceans began. The entire planet would have glowed grey or silver, its surface hidden beneath endless clouds reflecting sunlight like a giant mirror. Lightning would have flashed across both hemispheres, a continuous shimmer of electric veins dancing over a stormy globe. Each bolt released its energy into a world already buzzing with charge. Rain fell through air so dense it could carry particles of ash, dust, and molten rock suspended in its flow. The oceans forming below weren't clear blue. They were thick and murky, rich with dissolved minerals and metals stripped from the crust. These were the raw ingredients of future life, though life itself was still millions of years away from its first spark. As the rain sculpted the surface, it changed more than just the temperature. Water, the great solvent, began to draw elements out of rock: sodium, calcium, magnesium, iron, silicon. Every droplet carried away a trace of the planet's chemistry. Over eons, this relentless leaching built the ocean's composition, the balance of salts that defines seawater even today. The rain wasn't just carving the planet physically, it was shaping it chemically, preparing an environment capable of hosting the complex reactions that would someday give rise to life. So the storm wasn't merely destructive, it was deeply creative, though that creativity looked nothing like the calm blue seas we know. Imagine standing on one of the first pieces of solid crust to rise through the flood. The ground beneath your feet would be rough and dark, still warm from the heat below. The air would sting, a thick metallic mixture of steam and acid rain. Every breath would feel heavy. All around you, motion, waterfalls crashing from newborn ridges, geysers exploding from deep fissures, rivers disappearing into boiling mist before ever reaching an ocean. The sound would be overwhelming, not the rumbling of a modern storm, but the constant percussion of rain colliding with rock, of water meeting water, of clouds clashing miles above. It was a sound without pause, the heartbeat of a planet remaking itself drop by drop. That forgotten storm did more than carve the land. It changed time itself. As the planet cooled and water gathered into basins, Earth's mass began to redistribute. That shift altered its rotation. The moon, then much closer, raised massive tides in the young oceans, dragging against the planet's spin and slowing it down. Days lengthened, from just 6 hours to something closer to what we recognize now. The rhythm of the planet was being rewritten by water. The falling rain, the tides, and the shifting crust together stretched time in the most literal way imaginable. The same forces that cooled the surface also stabilized its spin, creating the predictable cycle of day and night that would one day guide every living thing. The storm, in its own way, was building the world's first clock. Beneath the surface, the crust was changing too. Rainwater seeped into fractures, cooling the magma below, solidifying minerals and forming the first granitic rocks, lighter than the basaltic crust around them. Those lighter patches began to rise, forming the ancient seeds of future continents. Even the tallest early peaks were temporary. Erosion tore them down almost as soon as they appeared, their remains carried away to deepen the oceans below. That constant cycle of building and wearing down became one of Earth's defining rhythms. In a sense, the planet learned endurance through erosion, learning to renew itself by surrendering, grain by grain, to the persistence of water. And while the surface transformed, the sky above changed as well. The dense shroud of water vapor slowly began to thin, as more and more of it condensed into rain and fell to the surface below. The storm had nearly run its course. With every drop that fell, the air thinned a little more. The endless shroud of cloud began to lift, and for the first time, sunlight touched the upper atmosphere. It wasn't bright at first, just a dim red shimmer filtering through miles of vapor. But it was a beginning. Slowly, the light strengthened, and the warmth that once baked stone began instead to settle into the water. That simple shift, heat held by oceans instead of rock, changed everything. It created differences in temperature between sea and sky, giving birth to the first weather patterns. The storm didn't vanish. It evolved. Winds began to organize, currents found rhythm, rain fell in pulses instead of endless sheets. The world was learning what weather meant. The forgotten storm also left a mark that still defines the air we breathe. As rain met volcanic gases, it pulled carbon dioxide and sulfur dioxide from the sky, locking them into solid rock as carbonates and sulfates. Over ages, that reaction thinned the greenhouse blanket that had kept the planet smothered in heat. Temperatures dropped, the surface stabilized. Without that relentless rain, Earth might have remained a burning wasteland like Venus, too hot, too volatile, too hostile for oceans to ever form. The difference between a planet of fire and a planet of life came down to the endurance of water. There's something oddly comforting in that idea. The same force that eroded mountains and drowned valleys also brought balance. It proved that destruction and creation aren't opposites. They're phases of the same cycle. The storm that never stopped wasn't a punishment. It was the earth taking a breath after its violent birth, a long exhale after the chaos of creation. And when it finally eased, What remained was calmer, cooler, and ready for transformation. The oceans that spread across the planet in its aftermath were vast, heavy, and strange. They weren't blue like ours, but murky, filled with minerals and suspended debris. The skies above still carried volcanic haze, tinting the sunlight a deep red. Across the horizon, dark, steaming islands rose through the mist, silent on the surface but alive beneath. Down below, chemistry stirred. Dissolved elements met the heat of volcanic vents, forming a restless, reactive soup. No living creature moved yet, but the ingredients of life were gathering molecule by molecule. The storm hadn't just built oceans, it had prepared a stage for biology itself. It's poetic, really. The process was entirely mechanical. Water falling, rock dissolving, gases condensing, heat escaping into space. Yet out of that raw exchange came the potential for complexity. Those churning seas of minerals and metal would one day cradle the first self-replicating molecules. Life would rise not despite the storm, but because of it. The planet had to weep before it could breathe. The same acidity that carved its surface also created the chemistry that made life possible. What once destroyed began to nurture. The rain stopped, but its purpose didn't end. Every drop of water that falls today still follows the same ancient law. The water cycle, evaporation, condensation, precipitation, isn't a modern system. It's the echo of that primal storm. The earth still breathes vapor in and releases rain out. The difference now is only scale. What once consumed the whole planet for millions of years now plays out in passing storms. The forgotten tempest never truly ended. It just slowed enough for us to exist beneath it. If you listen closely, you can almost hear that ancient world. The soft repetition of rain on water, the rumble of distant thunder, the hiss of steam rising from fresh stone. Those sounds have never left. They're written into every storm we know, a memory of when water first learned to fall. Rain isn't just weather, it's remembrance. Each drop carries molecules that once cooled a molten earth, carved valleys, and filled the first oceans. They've been recycled through clouds, rivers, and glaciers billions of times. When rain hits your window, you're hearing history, the planet retelling its oldest story in a softer voice. Eventually, the endless rain reached its balance. The oceans deepened enough to hold most of Earth's water, and the atmosphere settled into stability. The steam that had once fueled the storm thinned away. Light broke through. For the first time, sunlight consistently reached the surface, painting the planet in color. The grey gave way to blue seas and dark green crust. The earth was still raw, but it was beginning to look like a world we'd recognize. The forgotten storm had done its work. The planet was no longer a furnace or a flood. It was a home, waiting for life to arrive. Yet even then, calm was temporary. Heat still surged beneath the surface. Volcanoes still roared. The seas still shifted restlessly. The storm might have ended, but the habit of transformation remained. Earth had learned how to balance itself through cycles, heating and cooling, evaporation and condensation, creation and erosion. That rhythm would define everything to come. Even after the last torrents fell, the sky shimmered with moisture. The clouds, reluctant to leave, drifted slowly and released occasional showers, echoes of what had once been endless. The planet paused again between breaths. And beneath the waves, something extraordinary began. Simple molecules joined into complex ones. Chemistry became structure. Structure became memory. The oceans that rain had built were no longer just pools of water. They had become laboratories of possibility. The storm had prepared the world, and now the experiment could begin. After millions of years of unbroken rainfall, the earth was finally ready for its next miracle, the first spark of life. But that is another chapter. For now, what remains is the echo of the storm, the memory of a planet that learned to endure by learning to reign. The forgotten storm that never stopped wasn't just weather. It was the moment Earth learned balance, the first long breath after chaos. It was the sound of the planet finding its rhythm, a rhythm that still plays every time clouds gather and the first drop of rain touches the ground. The same water, the same endless cycle, a memory repeating itself across time, never truly forgotten. Before the rain came, Earth was a place we'd hardly recognize, a restless, glowing world, too young to understand calm or order. Its surface was a sea of molten rock, forever shifting, cooling, cracking, and reforming. Volcanoes covered nearly every horizon, thousands of them, each one releasing heat, gas, and light into an atmosphere thick with poison. The air shimmered with energy, heavy with carbon dioxide, nitrogen, and steam. Pressure crushed everything. The temperature was unbearable, and above it all hung a sky not blue or grey, but a dense haze of orange and red. Nothing about it hinted at the peace that rain would one day bring. This was earth before water, before clouds, before anything could fall from the sky except fire. It's hard to imagine a world without oceans. We're so used to calling our planet the blue world that it's strange to picture it any other way. But for hundreds of millions of years after its birth, Earth's surface was so hot that even metal and stone flowed like liquid. There were no continents, no rivers, no soft soil, only a churning, radiant surface glowing from within. The air was toxic and dense, trapping heat that the planet couldn't yet release. Earth was wrapped in a suffocating atmosphere made not of clouds, but of gases spewed endlessly from volcanoes. The crust was thin and fragile, floating like cracked glass over a molten sea. Beneath it, the core was still separating, heavier elements sinking inward, lighter ones rising outward. The planet was building its internal structure, but had yet to find stability. This was an age before balance, when heat and gravity wrestled for control. The Earth had only just survived its most violent beginnings. Massive collisions with other young worlds still scarred its surface, one so catastrophic it likely created the moon. That impact stripped away part of Earth's outer shell, sending molten debris into orbit, where it eventually fused into the moon we see today. The energy released by that collision kept the Earth glowing hot for millions of years. Temperatures at the surface soared far above the boiling point of any liquid. Any molecule of water that tried to form was instantly torn apart or vaporized. Rain was impossible. Clouds existed, but they weren't made of water. They were filled with ash, dust, and vaporized rock. And yet, even then, the seeds of rain already existed deep within the molten planet. Hydrogen and oxygen, the two elements of water, were trapped inside minerals and magma. Every eruption released a bit of that hidden water as steam. Over millions of years, those vapors built up in the air, slowly thickening the atmosphere with moisture. It wasn't much at first, just thin wisps of steam curling into a sky already crowded with heavier gases. But as the planet kept erupting, the air grew denser, more layered, more complex. If you could somehow stand there, the atmosphere would have pressed against your body like the weight of the deep ocean. But you couldn't. The ground was still too unstable, too hot, too bright. Earth was still deciding what kind of planet it wanted to be. The young planet existed in a solar system still full of chaos. The sun was smaller and dimmer than it is today, and space around Earth swarmed with debris, asteroids and comets left over from the birth of the solar system. Some of those comets carried ice, and when they collided with Earth, they added even more water to its growing atmosphere. Each impact delivered both destruction and gift, energy that melted rock and vapor that thickened the sky. Some scientists believe much of Earth's water came from these icy wanderers. Others think it was always here, trapped inside the planet's crust, waiting to be released. Either way, by the time the cosmic bombardment slowed, Earth was wrapped in a dense, suffocating blanket of steam and gas. It's hard to imagine what that sky looked like. It wasn't clear or open in any way we'd recognize. The sun would have been a faint orange blur behind miles of vapor. Any light that reached the surface was scattered and tinted by minerals and dust suspended in the air, creating a world of perpetual twilight, not dark, but never bright. The horizon would fade into the sky into the ground, everything shifting and shimmering in heat. It was a strange, alien beauty, one meant not for eyes, but for endurance. Earth wasn't a finished world yet. It was still being built. In those early days, the planet didn't have weather as we know it. Weather requires contrast, warm and cool, dry and wet, rising and falling air. But the young Earth was uniform in its chaos, heated evenly from below by molten rock and sealed in by a thick layer of gas. There were no winds, no storms, only slow, deep currents of hot air moving like invisible magma. Yet even in that heavy stillness, the first traces of future storms were forming. Each molecule of vapor that rose from the lava was a small, patient step toward rain. The landscape was ruled by volcanoes, not isolated peaks, but vast, connected fissures that stretched for hundreds of miles. Magma poured from them like rivers of fire, spreading across the surface before cooling and cracking again. Each eruption released more gas, feeding the sky that was slowly coming to life above. That sky, though toxic and heavy, was growing more intricate. Carbon monoxide, sulfur dioxide, ammonia, all thickened the air, making it darker and heavier, but also more chemically rich. Within that chaos, reactions were already beginning. Molecules combined and broke apart, forming compounds that would someday be essential for life. Earth was violent, but in its violence it was also creative. If you could have hovered above it safely, you'd have seen a world glowing through its own haze. Lightning flashed constantly, triggered by the static of volcanic ash. Each flash illuminated a restless surface, rivers of lava, pillars of smoke, craters still glowing at their edges. From space, the Earth would have looked like a burning ember wrapped in fog. Even then, it was clear. This was a planet in transition. The molten glow beneath was the memory of its birth. The restless sky above was the promise of what was coming next. The atmosphere of early Earth wasn't anything like the air we breathe today. Scientists call it a reducing atmosphere, a world without free oxygen, but thick with hydrogen, methane, and ammonia. It was a restless, reactive mix, a chemistry lab powered by chaos. Lightning flashed through volcanic clouds, ultraviolet rays bombarded the sky, and heat pulsed from a molten surface below. Every spark, every reaction, every collision between atoms was part of a vast and unseen experiment. The building blocks of life were still just whispers in vapor, yet the planet was already preparing for rain, for balance, for oceans, for everything that would one day live beneath them. The pressure during this age was crushing, hundreds of times greater than today. In that kind of heat and density, water couldn't yet exist as liquid. It lingered as steam, a suffocating shroud clinging to the molten crust. The planet was trapped in a paradox. It needed to cool for rain to fall, but the same gases that would create that rain were trapping the heat. It was a feedback loop that kept the world glowing far longer than it should have. Slowly, time and gravity began to work their quiet magic. Volcanic eruptions grew less constant, allowing more heat to escape into space. The upper layers of the atmosphere started to cool, and with that cooling came clouds, dark, dense, and towering. They weren't the soft white clouds we know, but vast mountains of chemical vapor streaked with metallic dust. Some may have reached hundreds of miles high, wrapping the planet in shadow. Within those clouds, the first raindrops began to form, but they never made it to the ground. The air below was still too hot, so each droplet evaporated mid-fall, turning to vapor before it ever touched the surface. Imagine a sky glittering with ghost rain, tiny beads of steam falling, vanishing, falling again. A rehearsal for what was still to come. Meanwhile, the surface below was changing. Rivers of lava cooled into brittle rock, cracking as they hardened, forming the first fragile crust. Every cooling cycle allowed more heat to escape, inching the planet closer to equilibrium. The clouds thickened, the air grew heavier, and condensation became easier. The world was on the verge of transformation, waiting only for a little more cooling, a little more patience. Then came the tipping point. When the planet finally cooled enough that rain could survive its fall, everything changed. The first true droplets hissed as they struck the rock, evaporating instantly. But they kept coming. Every drop that turned to steam carried away a trace of heat. Gradually, the feedback loop weakened and the surface began to yield. The skies, once only teasing with vapor, collapsed inward. It wasn't a storm, it was a deluge that lasted millions of years, a global rain that cooled the surface, carved basins, and filled them with the first oceans. The air thinned, the crust stabilized, and the world took its first deep breath. All of it began with something as simple as cooling. No miracle, no plan, just physics doing what it always does. Heat escaping into the vast cold of space. The same process that fogs a window or steams a kettle was unfolding on a planetary scale, stretched across unimaginable time. If you could watch those millions of years unfold in a single lifetime, it would look like a miracle. You'd see a fiery world dim to red, then to brown, then to grey, as thick clouds smothered its glow. Lightning would flash in a darkening sky. You'd hear the first rain hiss and vanish in steam. Then, at last, the downpour would come, relentless, endless, until the surface cooled and the molten light faded away. The earth would move from fire to water, from brightness to shadow. The planet would exhale, and the first real rain would begin. But before that moment, just before the sky gave way, the world stood in fragile balance, a breath caught between fire and vapor, a planet not yet solid, not yet blue, suspended in a shimmering haze of heat and steam. Below, volcanoes erupted in chains that wrapped the globe, spilling molten rivers across the surface. Each eruption fed the sky, releasing sulfur, carbon, and water vapor into the air. The horizon glowed red, the air shimmered, and the boundary between sky and ground blurred into one. It was a living planet, angry, luminous, and alive with motion. Both sky and earth were mirrors of each other, each one feeding the other's fire. And above that blur of heat and light, the first clouds waited, pregnant with the promise of oceans. If you looked up back then, you wouldn't see a sky the way we know it. Instead, you'd see a ceiling of smoke and vapor, rolling and crashing like an ocean turned upside down. The young earth wasn't divided into land and sky. It was a world of two seas, one of fire below, one of steam above, each feeding the other in a cycle of fury and creation. Scientists often describe this era as a planetary pressure cooker. The Earth was a sealed chamber of unimaginable energy. Heat, trapped deep within its core, struggled to escape, but the thick blanket of vapor overhead locked it in. The result was a greenhouse effect, far beyond anything we could imagine today. Temperatures at the surface hovered near 1,000 degrees Celsius. The crust, where it existed, was thin and unstable, constantly melting, breaking, and reforming. The planet was still cooking itself into being. And yet, amid the chaos, something extraordinary was happening. The same violent exchanges that kept the planet molten were also creating the chemistry of the future. Every plume of vapor, every flash of lightning, every surge of molten rock helped shape the early recipe for life. The atmosphere and the surface worked together as a vast laboratory. Gases and minerals collided and reacted. Iron rusted, silicates began to solidify, and simple molecules like methane, ammonia, and hydrogen sulfide filled the air. Each lightning strike sparked new combinations, creating traces of more complex compounds. The planet wasn't ready for life, but it was laying the groundwork for it. If you could have watched from a safe distance, hovering beyond the edge of the atmosphere, the view would have been breathtaking and unsettling. The Earth would have appeared wrapped in grey and white clouds, swirling like smoke over a hidden fire. Bursts of red and orange would flash through the haze as volcanoes pierced the cloud layer. Lightning would have flickered inside the vapor, like the pulse of something alive. From space, it wouldn't look like the blue and green world we know, but like a glowing furnace slowly covering itself in steam. Beneath that restless canopy, the surface never stopped moving. Rivers of molten rock carved through the crust, colliding, merging, cooling just enough to form jagged islands of stone, only to shatter and sink back into the molten sea. There were no continents, no stable ground, just shifting fields of glowing rock rising and falling like waves. The relationship between the fiery surface and the steaming sky wasn't just visual, it was symbiotic. The vapor above came directly from the molten rock below, released by eruptions and cooling magma. That vapor, in turn, trapped the planet's heat, slowing its escape. The hotter the Earth grew, the more vapor filled the sky. The more vapor there was, the longer the planet stayed hot. It was a feedback loop that defined this entire age, a delicate standoff between fire and steam that lasted millions of years. The balance eventually began to tip. Cooling from the upper atmosphere slowly started to win. Condensation gathered. The first true rain was close. But before it came, the world lingered in that fragile equilibrium. A planet caught between burning and cooling, holding its breath before the storm. If you could somehow stand within that atmosphere, it would feel like moving through water. The air was dense, the heat unbearable, the humidity absolute. The pressure might have been hundreds of times stronger than what we experience at sea level today. Above you, the sky would glow with shifting colors, grey, yellow, deep red, as volcanic light filtered through the clouds. The world would not have been quiet. The air would have thundered with the sound of creation, eruptions, lightning, molten rock cracking, and rain that turned to steam before it touched the ground. Everywhere the same pattern repeated. Volcanoes belched plumes of gas and ash high into the air, reflecting heat back toward the surface. Below, the rivers of lava cooled into solid crust, only to fracture again as new magma surged upward. The planet's skin was in constant motion, expanding and contracting, breathing in its own fiery rhythm. Those volcanic gases didn't just build the atmosphere, they changed it. Carbon dioxide and water vapor thickened the greenhouse veil, while sulfur compounds helped shape the planet's early climate chemistry. What we now call environmental balance was in those days nothing more than physics, heat, pressure, and chance endlessly reacting with one another. In many ways, this was the most dramatic transformation Earth would ever experience. Later ages would bring continents, climates, and life, but none would alter the planet so completely. This was the foundation, the formation of a stable crust, the accumulation of a dense atmosphere, and the long cooling of the molten mantle. Without this age of fire and steam, there could never have been oceans, clouds, or air to breathe. The planet had to endure extremes before it could learn balance, and when the first true clouds finally appeared, not just vapor, but real water clouds, they would have been unlike anything we've ever seen. Massive, unbroken systems stretching thousands of miles across, their tops reaching into the highest layers of the sky, where at last the temperature was cool enough for condensation to begin. They were the first sign that the age of fire was ending, and the age of rain was about to begin. The condensation in the sky didn't bring calm, it unleashed even greater chaos. The energy released from cooling vapor fueled colossal storms, driving updrafts and lightning that made modern weather look tame. Each strike carried enough raw power to tear molecules apart and rebuild them into something entirely new. Many scientists believe those tempests were more than just destructive, they were creative. Inside those flashes of fire and thunder, nature may have assembled the first building blocks of life. Amino acids, hydrocarbons, and organic molecules that would one day become the foundation for everything living. It's a haunting image, a world at its most violent, also at its most fertile. Creation and destruction playing on the same stage. In the boiling skies of early Earth, chemistry was being driven by both extremes, the scorching heat below and the relentless cooling above. The atmosphere became a vast, churning laboratory, endlessly experimenting, breaking, and remaking the ingredients of existence. Every volcanic eruption poured new material into the air. Every cooling phase pulled it back down again. The entire planet was locked in a massive experiment, testing every possible combination of elements, waiting for one that would someday take a breath. Meanwhile, deep within the molten oceans, another process was shaping the planet's destiny. Convection. Currents churned through the liquid rock, slowly carrying heat away from the core. Magma rose toward the surface, cooled, and then sank once more into the depths as it became denser. This endless cycle helped the planet release its internal heat and began to stabilize its surface. The first crust that formed during this time was thin and fragile, constantly breaking and reforming. But it was a beginning, the birth of geology itself. For the first time, Earth had a surface that could move, shift, and renew. Tectonic forces were awakening even before the first drop of rain had fallen. The planet had developed its own heartbeat, a slow, rhythmic pulse of creation and destruction that would continue forever. For millions of years, this world of fire and steam endured. Heat bled away. The atmosphere cooled. The tension between sky and surface grew sharper until finally the balance tipped. The air could no longer hold its burden of vapor. Tiny droplets began to form, first as mist, then as clouds heavy enough to fall. The first rain had begun, but the surface was still too hot. Every drop that reached the ground exploded into steam, vanishing on contact. Yet each drop also carried away a trace of heat, cooling the planet bit by bit. Slowly the balance shifted. Then the inevitable happened. The sky itself collapsed. The vapor that had blanketed the earth for eons condensed into liquid, and gravity pulled it down in an endless cascade. It must have been a sight beyond imagination, the entire sky falling as rain. The boundary between heaven and earth vanished. Steam roared upward as rain struck molten rock, and the cycle repeated across the globe for millennia. The ocean was not carved by rivers or glaciers. It was born from the air itself. The sky of steam was transforming into a sea of water, and the molten surface beneath it was finally beginning to cool. It didn't happen overnight. It took countless years, but once the process began, it could not be stopped. The greenhouse veil that had trapped the planet's heat was thinning. The rain was pulling carbon and other gases from the atmosphere, dissolving them into the newborn oceans. The crust grew strong enough to hold its shape. Volcanic fury still flared, but the balance was shifting from fire to water. Earth was shedding its molten skin and trading it for a liquid one. It's humbling to think about. The oceans that now cradle life and shape our climate were born from that tension between heat and vapor. Every tide, every wave, every droplet is a remnant of that transformation. The water that fills our seas once floated above a world that couldn't yet rest. The rain that gave birth to the oceans didn't fall from rivers or ice. It fell from the sky itself, condensed from a vapor that had wrapped the planet for ages. It was a simple exchange of energy, but on a scale so vast it reshaped an entire world. When the last of the steam finally fell and the temperature steadied, Earth entered a new chapter. The once fiery surface was now wrapped in water, its glow replaced by reflection. Clouds still drifted, but they no longer smothered the sky. Light broke through for the first time, scattering blue across the air. The age of fire had ended. The sea of flame had become the sea of life's potential. The crust had finally cooled enough to hold continents, small, scattered fragments of land rising from a restless sea. Above them, the first complete cycle of rainfall, evaporation, and condensation had begun. The water cycle was alive. The story of a sky made of steam and a sea made of fire is, at its core, the story of transformation through endurance. The earth didn't decide to become a water world. It simply followed the laws of nature. Heat always moves toward cold. Vapor always seeks condensation. Chaos always moves toward balance. The rain that would fall for nearly 2 million years wasn't a miracle. It was the inevitable outcome of those laws at work. What began as pressure found release. What began as fire found calm. The world had been forged by its own extremes, and through that trial it became capable of everything that would come next. But even as the last clouds of steam thinned and the surface began to settle, the planet's transformation wasn't finished. The oceans had formed, but the rain still had work to do. It had minerals to dissolve, gases to strip from the sky, and temperatures to regulate. The balance had shifted, but the process continued. Earth had entered its long, wet age, a time when the sound of falling water would echo endlessly, reshaping mountains, valleys, and basins until the planet was ready for the next chapter of its story. Somewhere in that vast span of time, between vapor and flame, there must have been a single moment when the first true raindrop reached the ground. Not steam, not mist. A real droplet, cool enough to survive the fall. Maybe it struck a ridge of darkening rock and vanished in an instant, leaving behind a whisper of vapor that rose back into the haze. Maybe it landed on molten stone, hissing as it disappeared. It wasn't special, not conscious of being first, but that moment marked something irreversible. The planet had crossed a threshold. Rain could now exist, even for a heartbeat. The sky was no longer made entirely of steam. The cycle that had once been only chaos had finally learned rhythm. From that first drop onward, the rain never truly stopped. What had begun as vapor falling into fire became an endless dialogue between water and stone. Every droplet that reached the surface carried a quiet power, the ability to carve, to cool, to change. As the crust thickened and stabilized, rainwater began seeping into cracks and fissures, dissolving minerals from the newborn rock and carrying them back toward the forming seas. The air above was still heavy with steam and carbon dioxide, but the rain was cleansing it, drop by drop. Each cycle drew gases out of the sky and into the deepening waters below, slowly rewriting the planet's chemistry. Over time, the oceans darkened. They became rich with dissolved metals and minerals, iron, nickel, sulfur, all washed from a restless crust that was still alive with heat. Lightning continued to flash through the clouds, splitting molecules apart, sparking reactions in the air and in the water. The planet had become a vast, natural laboratory, testing the boundaries of what chemistry could do. The first true oceans were unlike anything that exists today. They were hot, acidic, and dense with elements in constant motion. They boiled along the edges where magma met water, releasing plumes of minerals and gases that churned the surface into chaos. But in that chaos, something new was forming: balance. Each eruption, each storm, each cooling tide brought the planet closer to equilibrium. The cycle between the fiery core and the cooling sky had become a loop of creation. The crust fractured and healed, the oceans filled and boiled, the sky rained and cleared, and slowly the earth began to breathe. If you could have stood above it then, somehow shielded from the heat and the roar, you would have seen a world in constant motion, a sky streaked with lightning and clouds the color of metal, oceans that glowed faintly red from the reflection of volcanic fire below, a planet alive but still searching for stability. And yet, within that unstable mix, the foundation for life itself was already being laid. The minerals dissolving in those early seas would become the ingredients of biology. The gases in the air, methane, ammonia, hydrogen sulfide, would soon meet the energy of lightning and sunlight to form complex molecules. It was chemistry on the edge of miracle, a world transforming not by chance, but by the steady, inevitable rhythm of its own physics. The Earth was no longer just a planet of fire and water. It had become something more, a world capable of remembering its own reactions, a world preparing, unknowingly, for life. The rain had reshaped the planet. What was once a glowing sphere of molten rock had dimmed into a world wrapped in cloud and ocean. The surface, once hostile and blinding, was now dark and restless, veiled by mist and storms. The first true seas had settled, deep and hot, their surfaces shivering under endless rainfall. Steam still rose from every ridge where magma met water, blurring the line between air and sea. Inside those waters, something extraordinary was happening. The rain that fell for millions of years carried more than just heat and minerals. It carried the potential for chemistry, the restless drive of atoms to join, to break, and to rejoin in new forms. The lightning that flashed across the dark sky tore through the air, splitting molecules into pieces that recombined into new compounds: methane, ammonia, carbon dioxide, hydrogen. They danced together in the electric light, forming the building blocks of what would one day be called life. The oceans had become a cauldron. Each wave stirred a mixture of elements. Each droplet contained traces of carbon chains and primitive amino acids. There were no cells, no membranes, no life, not yet. But the recipe was there, waiting. The entire planet was an open experiment, a vast chemistry set powered by fire, water, and lightning. Scientists today call this period the Hadean Eon, a name that evokes both hell and beginning. And it fits. The earth then was violent but creative, destructive yet fertile. Every eruption that blackened the sky also released gases that would later form rain. Every storm that raged across the ocean brought energy that could forge new compounds. The same forces that could destroy were also the ones that built. Deep in those early seas, near cracks in the cooling crust, heat and minerals rose from the planet's interior in shimmering columns. These were the first hydrothermal vents, natural forges of chemistry. Around them, the water was rich with sulfur and iron, constantly shifting between boiling and freezing. It was here, many scientists believe,
that the first stable organic molecules found refuge, protected from ultraviolet radiation, shielded from the chaos above. These vents became islands of order within a storming planet. The chemistry that happened there wasn't random. It followed the same quiet logic that had shaped the planet itself. The movement of energy from high to low, the search for balance. Molecules formed, broke apart, and reformed endlessly, like the rhythm of tides. Some combinations lasted longer than others. Some began to store energy. Some even started to replicate, though not in any biological sense yet. Just simple reactions echoing themselves again and again. It was a prelude to life, a whisper before the first breath. If you could have looked into those early oceans, you wouldn't have seen anything alive. No fish, no plants, not even bacteria. Only swirling clouds of minerals suspended in water that shimmered with faint light. Yet within that shimmer, the foundation of biology was taking shape. Each molecule carried the potential to become more. Each reaction was a small step toward complexity. Above the surface, the storm still ruled. The sky was heavy with lightning, and the air was dense with vapor and gas. The young sun, dimmer than it is now, cast a weak golden light through the haze. Every sunrise was muted, every horizon blurred. But the planet was stabilizing. The crust grew thicker, volcanoes erupted less often. The oceans deepened, spreading across vast basins that reflected the faint light of a clearing sky. As the temperature dropped, the steam began to thin. The rain slowed from an endless torrent to a steady rhythm. Clouds broke apart, revealing patches of pale blue. For the first time in its history, sunlight touched the surface of the oceans directly.
The earth was no longer just surviving its own birth, it was beginning to breathe. Those first rays of sunlight changed everything. They brought new energy to the chemical dance already underway in the oceans. Molecules that had formed in darkness now reacted under light, forming new compounds never seen before. The same light that once scorched the planet was now shaping it, driving reactions that would one day lead to photosynthesis, metabolism, and life. It was a fragile balance, light above, heat below, chemistry in between. But in that fragile space, life's story had its first chapters written. The air was still unbreathable, thick with carbon dioxide, methane, and sulfur gases, yet the ocean beneath it had become a sanctuary, the only place where molecules could endure, change, and persist long enough to matter. The water absorbed the ultraviolet radiation that would have destroyed them, and the minerals from volcanic vents gave them structure. Every wave, every spark of lightning, every pulse of heat from the mantle added to the experiment. The world was still chaotic, but the chaos had purpose. The energy that once melted rock was now fueling reactions at a microscopic level. The planet had cooled enough to stop burning, but not enough to stop creating. If the story of Earth began with fire and storm, this was the first moment of calm. A calm that allowed chemistry to breathe, to evolve, to take its first small steps toward what would one day be life. Somewhere in that vast ocean, a cluster of molecules found stability, a combination that didn't fall apart immediately. Maybe it stored a bit of energy, maybe it could react with its surroundings in a way that helped it persist. It wasn't alive, not yet, but it was close. It was the spark before the flame, and so, after millions of years of fire, storm, and endless rain, the earth had finally created the one thing it had never known before: potential. The potential for memory, for replication, for evolution. The potential for life. What began as fire had become water. What began as chaos had become balance. And what began as mere chemistry had become the first whisper of biology. The world had changed, not with a bang, but with a quiet, patient shift. From that moment on, the Earth was no longer just a planet. It was a cradle. The ocean had become a mirror, dark, heavy, and alive with invisible motion. Every droplet contained a history of heat and light, a quiet memory of the storms that had forged it. Deep below the surface, the planet was still restless. Hydrothermal vents pulsed like the heartbeat of the world, releasing plumes of mineral-rich water that curled upward into the dark. In those swirling clouds of heat and chemistry, something new began to stir. The molecules drifting through those early seas were not random anymore. They had begun to favor patterns, structures that held together longer, shapes that repeated. Some could trap energy from their surroundings. Others could cling to mineral surfaces, forming fragile films that organized themselves into layers. It was still chemistry, but now it was chemistry with rhythm. No one can say exactly how it happened, whether it began near a volcanic vent, a tidal pool, or somewhere we can no longer imagine. But at some point, a simple molecule did something extraordinary. It copied itself. Not perfectly, not consciously, but enough to persist, enough to matter. That moment, the first replication, was the true beginning of biology. From then on, every reaction, every spark of energy in the ocean was part of a growing network of possibility. Molecules began to assemble into chains and rings, into membranes and patterns that echoed life's future designs. Some broke apart, others fused together, but through it all, the planet's chemistry was learning how to sustain itself. The conditions were perfect for creativity. Heat from below, sunlight from above, and minerals in between. Iron, sulfur, and carbon formed bridges between molecules, turning random reactions into tiny circuits of energy. The oceans became alive with experimentation, a billion invisible attempts at persistence. Imagine looking down into those waters then. You wouldn't see life, but you'd sense movement, a shimmer, a pulse, a vibration in the depths. Every particle was charged with potential. Every reaction left a trace for the next one to follow. The world was beginning to remember itself. The earliest organic structures were fragile. They formed and collapsed in seconds. Yet with each cycle, the survivors, the most stable combinations, became slightly more complex. Some could trap bits of energy from heat or light and use it to drive chemical change. Some formed bubbles, tiny pockets where reactions could happen in isolation. These were the first primitive membranes, ancestors of the cells that would one day populate every ocean, every forest, every body.